This piece of steel has spent decades quietly surrendering to the elements. Today, one craftsman starts the long process of pulling it back. The original wooden handle is beyond saving, deeply compromised by termite damage and rot. Stripping away the decayed exterior is the necessary first step to expose the steel core underneath. Underneath the ruin, the underlying tang reveals heavy pitting and structural oxidation. The real condition of the metal can only be assessed once the rot is completely cleared. With the initial surface rust scraped away, attention turns to the foundation of the new grip. The builder selects a dense hardwood block, chosen specifically for its compressive strength and resistance to splitting. Carving a precise channel into the center requires controlled, incremental strikes. A sharp chisel severs the wood fibers cleanly, rather than crushing them, which maintains the structural integrity of the surrounding block. This internal groove must exactly match the dimensions of the rusted tang. Even a millimeter of excess play here would translate to a loose, unstable handle once the knife is fully assembled. A perfectly flush fit ensures the force of every future cut transfers directly into the blade. To chemically stabilize the severely pitted metal, a specialized rust conversion bath is prepared. This thick, viscous liquid contains compounds that react directly with iron oxide. Agitating the mixture with a power drill ensures the active chemicals are evenly distributed. Poured into a custom acrylic mold, the heavy fluid creates an oxygen-deprived environment. Submerging the steel in this dense mixture will halt the active decay and prepare the surface for deeper restoration. Hours of chemical soaking yield a neutralized surface, ready for thermal manipulation. The blade is introduced to the deep, steady heat of a coal forge. Raising the steel's temperature reorganizes its crystalline structure, relieving internal stresses built up over decades of harsh use and exposure. While the steel absorbs the heat, a brass bolster is roughly shaped with a flat file. Brass is a softer alloy, making it ideal for a guard piece that must compress slightly against the harder steel tang to form a moisture-resistant seal. The blade is then cycled back into the forge. Consistently maintaining this critical temperature is essential before wrapping the metal in foil, a technique used to slow the cooling process. This controlled descent in temperature anneals the steel, leaving it soft enough to grind and refine without fracturing. A secondary chemical phase is necessary to strip away the stubborn mill scale left by the forge. Dry acid granules are poured evenly into a long trough and activated with water. This volatile mixture creates an aggressive, localized etching environment. As the blade sits in the bubbling solution, the acid actively eats away at microscopic surface impurities and carbon deposits. The reaction strips the top layer of weakened material, revealing the true bare steel underneath. When the blade emerges, the bright metal has been replaced by a dark, textured finish. The steel is finally clean. With the chemical treatments complete, mechanical refinement begins. The etched surface is leveled using progressive grits of abrasive paper. Sanding along the length of the blade, rather than across it, aligns the microscopic scratch pattern with the intended cutting direction. This directional finish reduces drag when slicing through dense material. Moving to a finer grit abrasive burnishes the metal, flattening the microscopic peaks left by the rougher paper. The result is a clean, uniform brushed finish that strongly resists future oxidation. Following the high-gloss buffing, the tang requires structural modification to secure the new grip. High-carbon drill bits bore precise anchor points through the softened steel to permanently protect. The finished surfaces from corrosion, the blade is submerged in an electrochemical bath. By running a direct electrical current through a specialized liquid solution, metallic ions bond to the surface at a molecular level, leaving a distinct golden tint. This anodic coating forms an incredibly hard, sacrificial barrier against moisture. Returning to the vise, the final edge geometry is established with an angle grinder. The craftsman refines the bevel angle, carefully balancing the thickness of the spine with the acute taper required for the cutting edge. The final metallurgical phase requires locking in the steel's hardness. The blade is returned to the intense heat of the forge, bringing it up to critical temperature. A vertical quench tube is prepared nearby to house the cooling oil. The steel must soak in the heat until it glows a very specific shade of cherry red, indicating the carbon molecules have properly dissolved into the iron. Matrix. While the freshly hardened steel normalizes, fabrication of the custom handle components begins. An oversized block of brass is rough cut with an abrasive disc. The raw edges left by the grinder are highly irregular, requiring meticulous hand filing to ensure a perfectly flat mating surface. This brass guard serves a dual purpose. It visually transitions the grip into the blade, and it mechanically blocks moisture from seeping down into the wooden core of the handle. Fitting the bolster involves constant checking and refining. Even microscopic gaps will trap water and invite internal rust. The metal is painstakingly smoothed with progressively finer abrasive paper, erasing the deep gouges left by the file until the brass yields a flawless, polished transition. The finished brass bolster is tapped securely over the tang, locking tightly against the shoulders of the blade. With the forward barrier in place, the primary wooden scales can be shaped. Using a hand saw prevents the aggressive heat buildup that power tools can cause, which might scorch or warp the thin wooden blanks. The exact profile of the steel tang is traced directly onto the wood. Transferring these dimensions manually is the only way to ensure the contours will align seamlessly. Finally, a power drill punches through the scales, perfectly matching the anchor holes drilled previously in the steel. These channels will house the metal pins that lock the entire grip together against shear forces. A high-strength structural adhesive forms the invisible bond between the dissimilar materials. The yellow epoxy is applied generously to fill any microscopic voids between the wood grain and the steel tang. Temporary alignment pins are driven through the drilled channels to keep the scales perfectly centered while the viscous glue sets. Once aligned, heavy spring pressure is applied. Clamping forces the excess adhesive out of the seams, compressing the joint into a single, unified block. The goal is to achieve an adhesive line so thin it practically disappears. A few gentle taps from a hammer ensure the wood sits completely flush against the brass guard, eliminating any structural weakness near the front of the grip. The assembly must now cure undisturbed. With the wooden core established and ground to its rough profile, the pommel requires a more resilient cap. Animal bone has been used in tool making for millennia, prized for its high density and excellent shock absorption. The dense calcium structure is notoriously difficult to machine, requiring slow, deliberate strokes with a fine-toothed hacksaw to prevent splintering. Drilling the bone generates intense friction and a distinctive, heavy dust. The hollow core of the bone must be securely pinned to the rear of the tang. A fresh batch of epoxy is mixed and spread evenly across the mating surface, preparing this durable cap to absorb the blunt impacts the back of the knife will eventually endure. Following the final contouring of the mixed media grip, a solid brass pin is driven through the bone pommel, permanently locking the assembly together. A mist of clear sealant is applied to the handle. This finish penetrates the pores of both the wood and the bone, defending the organic materials against moisture and the natural oils from a user's hand. The restoration culminates at the whetstone. Drawing the steel across the wet abrasive hones the edge to a microscopic, razor-sharp apex. What was a decayed, rusted artifact, bound for the scrap pile, is a working tool again, revived, robust, and functional. The harmony of hardened steel, polished brass, and natural handle materials proves that careful engineering can reverse decades of neglect. Some things are worth the long road back.